Hello, my name is Takia Robinson, and I am a rising junior from Norfolk State University. Today, I will be discussing the growth of single crystals using the optical floating zone technique. The objective of this project is to grow high-quality, non-symmorphic single crystals and determine their effectiveness as a new quantum material. Certain crystals not only have conductive properties, but they also have stable vibrations, which create electric signals with precise frequencies. A crystal with both abilities, such as bismuth copper oxide, has the potential to be used to build quantum computers or electronics with high energy efficiency due to their capacity to exploit correlated electron effects. Superconductivity is an example. To grow single crystal samples of bismuth copper oxide, a ceramic rod composed of bismuth oxide and copper oxide is created and melted until both oxides reach a liquid phase. As the rod melts, an incongruent melting scenario occurs due to the different melting points of the two oxides, causing melting to not be uniform. As the melt begins to cool, bismuth copper oxide will crystallize from the melt. The ceramic rod is composed of copper oxide and bismuth oxide powders in a 1:1 molar ratio. These oxides are mixed and ground into a fine powder and sintered in an oven or furnace for 72 hours at 700 degrees Celsius. This process is done twice before pressing the powders into a rod via hydraulic press, and the rod is then sintered a third time. After the rod has been sintered, a small portion is removed, ground, and brought in to undergo X-ray diffraction, or XRD, to calculate the purity of the crystal structure. Then, approximately 2.5 centimeters of the rod is severed. This part becomes the seed rod, while the larger portion becomes the feed rod. In theory, the feed rod hovers over the seed rod and melts onto it, forming the crystal. To achieve the melt conditions, the optical floating zone technique is implemented. Halogen lamps are focused on the ceramic rods and heated via the light absorption by the material. This method allows for faster, high-quality crystal growth from the melt. According to the XRD of the powder sample, the material would produce a pure bismuth copper oxide crystal. The results of the optical floating zone reflected the XRD initially. However, shortly after crystal formation, impurities began to appear in the crystal. Due to limited data collected, it is unknown whether this occurrence is due to the growth method or possible exposure to a contaminant. To recap, bismuth oxide and copper oxide powders were mixed and sintered twice, then pressed and sintered to create ceramic rods. The XRD showed that the rods created would yield pure crystals. Once in the zone, the rod was melted by the halogen lamps, then allowed to cool. This causes the oxides to crystallize. However, after the crystallization process, the crystal produced started to show impurities, and it is unknown what caused them. Once again, I am Takia Robinson from Norfolk State University, and I thank you for listening to my presentation.